All right, one more video for this week. It goes along with the exact same topic of the first video, so we're still solving quadratics by factoring, except for our a value is greater than 1 in all of these examples. Don't forget that your first step is always make sure that your equation is set equal to 0. Make sure you rearrange it if it is not set equal to 0. If it is set equal to 0, then factoring, we always want to find the GCF first. Always check for that. In this case, if we're looking just at the coefficients, 3, 9, and 12, we do have a GCF. 3, 9, and 12, the GCF is 3, okay? If we look at then our variables, x squared, x, and then in the last one, there's no x, so they don't have a GCF of the variable, so 3 is the GCF. So we'll pull out 3 and then divide everything by 3, the GCF. So 3x squared divided by 3, we're just left with x squared. 9x divided by 3, we'll get 3x. And then minus 12, so negative 12 divided by 3 is minus 4. Okay, and we can always double check. I would make sure it goes back. So 3x squared plus 9x minus 12. All right, it is the same. Okay, then I would factor what's in the parentheses, our polynomial x squared. Now, since we pulled out the GCF, the a value is actually 1 in front of that x squared. So this is very similar to our last video where we know both binomials are going to start with x. We still want to pull down that GCF of 3. All right, our c value is negative, so we know one has to be positive, one has to be negative. We're looking for what multiplies to negative 4 but adds to 3. So let's see, we have negative 4 and 1, so our higher, okay, so it's the middle number is a positive 3, we know that the bigger factor has to be positive. So if we use positive 4 and negative 1, that multiplies to negative 4, and it adds to 3. So the positive is a 4, and the negative is a 1. In this case, all of these terms are set equal to 0. So 3 equals 0. Well, that's an untrue statement. We know those two don't equal each other, so that one's false. That's not a solution. And then we set x plus 4 equal to 0 and x minus 1 equal to 0. So to solve for x, we'll subtract 4, so x is negative 4. And then we also add 1 to get x by itself, so x is 1. So x is negative 4 and 1. So there's that one. That's very similar to one of the examples we did in the last notes. Now, if we look at the next example, 2x squared plus 3x minus 5, if we look at our coefficients, there's no GCF besides 1. So we can't pull out a GCF. So in this case, me personally, we learned a little different in class, but the a value is prime, so we know the only possibility is for one to be 2x and the other one to be x. And then our c value is negative 5, so we know one has to be positive, one has to be negative, but we aren't sure which one because this time they aren't the same terms in the beginning. One's 2x, one's x. So in this case, we have to find out what multiplies to negative 5, but then adds to positive 3. Now, the c value is also prime. We only have options of 5 and 1. That's all. Sorry, my dog is next to me drinking some water, so hopefully you can't hear her. So our only options are 5 and 1 here. So I'm going to throw in, this is just my guess and check method. I'm going to throw in 5 here and 1 here. So if we do 2 times 1 for our O, we'd get 2 and then 5. Well, that's not going to work. We do have to make one positive, one negative. So the bigger one has to be positive. So now let's see, 2x, this 2x times negative 1 would be negative 2. and then plus 5, that would give us positive 3. And then 5 times 9, I ironically guessed on my first try. But this is my guess and check method. And then the same thing, we're going to set them equal. So 2x plus 5 equals 0, and x minus 1 equals 0. So the right side factor is easy, plus 1, so x equals 1. This one we would subtract 5, so 2x equals negative 5, and then divide by 2, so x equals negative 5 halves. So we have two answers, again, negative 5 halves and 1. All right, at school, Miss H taught you the slip and slide method. So I'm going to come off to the side here. Remember, that means we take the a value of, all right, that won't go away. Interesting. The a value of 2, and we multiply it by c, and then we rewrite that polynomial. So we'd have x squared plus 3x minus 10, and then we would factor this. So we'd have x. We know 1 has to be plus, 1 has to be minus, since the c term is negative. So what multiplies to negative 10 but adds to 3? So we would want the bigger factor positive and the smaller factor negative. So let's see, 5 and negative 2 do multiply to negative 10. 5 plus negative 2 is positive 3. So that works out. But then don't forget, the slip and slide method means we would take what we multiplied, the a value, 2 over here, and divide both these by 2 and simplify it. So 5 over 2 we can't simplify, so that would stay. And then 2 divided by 2 is 1, so x minus 1. And then we would slide this back in front. So 2x plus 5 and x minus 1 set equal to 0. If you notice, that is exactly what I got over here when I did my guess and check method. So if we solved those, if we set both of them equal to 0 and then solved for x, we would still get x is negative 5 halves and x is positive 1. All right, so the only difference is our a value is greater than 1. You still want to factor and then set both of your binomials, set equal to 0, solve for x, and there's your solution. All right, thank you guys.